A scatter diagram is a chart that portrays the relationship between the two variables. The y-axis represents the value of dependent variables and the x-axis represents the value of independent variables. So y depends on x. We have three types of correlations. Positive linear correlations, where this is the example for scatter diagram. As we can see, as the value of x increase, y also increase. And we have negative linear correlations. When x increase, y decrease. So this has negative slope. And no correlations, where there is no noticeable patterns on the scatter diagrams. The data is widely scattered. Example 1. The table shows the value of two variables x and y. By plotting a scatter diagram, explain the relationship between the two variables. So we have x and y. And scatter diagrams, we have x on x-axis and y on y-axis. Plot the data when x equal to 10, y equal to 2. So here, when x equal to 4, y equal to 9, and the rest of the data. This is the scatter diagram for the data looks like. And as we can see, there is a noticeable slope on the graph, where we can see as x increase, y decrease. So x and y have a negative linear correlation. Example 2. The above table shows the marks obtained by 10 students in a math test and an English test. Plot a scatter diagram for the above information, hence interpret the result. So a scatter diagram, x is math and y is for English test. So for student A, when x is 20, y is 30. And plot for the rest of the student. B 23. This is the scatter diagram for this data. So we can notice that when x increase, y also slightly increase. Therefore, x and y have a positive linear correlation. The coefficient of correlations is a measure of the strength of the linear relationship between the two variables. And this strength is measured by Pearson's coefficient given by this formula. The value of r is from -1 to 1, and we can interpret r using this guideline. When r equal to 0, there is no correlation. When r equal to 0.5, it is a moderate positive correlation, and -0.5 is moderate negative correlations. When r equal to 1, this is a perfect positive correlations. When r equal -1, this is a perfect negative correlations. And when r is between 0 to 0.5, there is a weak positive correlation. And from 0 to -0.5, weak negative correlations. And when r between 0.5 to 1, it is a strong positive correlations. And the last one is for r between -0.5 and -1, it is a strong negative correlations. Coefficient of determinations, r squared. R squared is called the coefficient of determination and is the percent of the total variation in the dependent variable y that is explained or accounted for by the variation in independent variable x. So r squared is coefficient of determinations, where how many percent y depends on x. The value of r squared is from 0 to 1. So r squared cannot be negative. For example, if r equal to 0.9710, then r squared is 0.9429. Then r squared equal to 0.9429 means that 94.29% of the variation in y is explained by variation in x, and 5.71% of the variation in y is caused by other factors. means 94.29% of what happens to y is caused by x. In general, this is the interpretation that you need to remember. R equal to value of R means that there is a strong, weak or perfect correlation between y and x. R square equal to value of R square means that change to percent of the variation in y is explained by variation in x. Example 1. From the data given above, find the Pearson's product moment coefficient of linear correlations R. R is given by this formula, and we need to find every value in this formula. So total of x equal to 18, where total of x is 3 plus 1 plus 2 plus 4 plus 5 and last one plus 3. And total of x square is sum of the square of x, 3 square plus 1 square and so on, equal to 64. And total of y is 64. The sum of the value of y, 10 plus 8 plus 7 and so on. Total of y square, also the sum of the square of y, 10 square plus 8 square plus 7 square and so on. And total x times y equal to 3 times 10 plus 1 times 8 plus 2 times 7 and so on. And n is 6. Then substitute this into formula. So we have r equal to 0.9269. Always take 4 decimal places. B, coefficient of determinations R square. So R square equal to the square of R. 0.9269 square is 0.8591. Interpret the value of R and R square obtained. So this is from the interpretations. R equal to 0.9269 means that there is a strong positive correlation between x and y. R square equal to 0.8591 means that 85.91% of the variations in y is explained by the variation in x. Example 2. The manager of a hypermarket believed that the customer spending y per month is related to monthly income x. A study on 7 customers give the following data. So A, find the Pearson's product moment coefficients of correlations R and comment on the result. So customer spending per month is y and monthly income is x, and Pearson product moment is given by the formula R, and all the data is already given. Just substitute into the formula, we get 0.995. So R equals 0.995 means that there is a strong positive correlation between customer spending y per month and monthly income. B, how many percent of variations in customer spending per month can be explained by monthly income? The variation in customer spending means we need to find R square, which is equal to 0.995 square equal to 0.99. So 99% of the variation in customer spending per month can be explained by the monthly income. This is your exercise. Please submit the exercises at the end of lecture.